Good day, students. On this clip, we're going to be going over two examples on logarithmic differentiation. So this is part two of a two-part series. So let's go ahead and take a look at the first example. Well, the instructions for both of them are as follows. Find the derivative of the following. Okay. All right. So the first function we're going to look at is y equals 1 plus 5x raised to the sine x power. Okay? So the first thing we're going to do is we're going to take the natural logarithm of both sides. So we take the natural logarithm of y equals the natural logarithm of 1 plus 5x 1 plus 5x raised to the sine x power. Okay? Alright, so the first thing we're going to do, if you take a look at the term on the right side, we're going to make use of the power property of logarithms, okay? And it's as follows. It says if you have ln of a raised to the nth power, you can bring this power down as a coefficient of the natural log, so it's the same thing as n times the natural logarithm of a. Okay? That's an n right here. So the power can come down. So that's what we're going to do here. This power, 1 plus 5 plus 5x, can be brought down to the front of this natural logarithm right here, using this power property of natural logarithms. Alright? So if we apply that, we're going to have the natural logarithm of y equals sine x times the natural logarithm of 1 plus 5x. So the benefit of taking the natural logarithm of both sides is that we can get to bring this power down, and we can then apply the product rule in the differentiation of the right side. Okay? So now what we're going to do is we're going to differentiate both sides implicitly, and then we'll isolate y prime, which is the derivative. So differentiating the left side, we know the derivative of ln x is 1 over x, so ln y is 1 over y. So the derivative here is going to be 1 over y, using the chain rule, as the derivative of ln y times y prime. On the right side, we have to use the product rule. Just a real quick review, if we have uv prime, the product rule tells you that you just multiply the first function times the derivative of the second function plus the second function times the derivative of the first function. In this case, sine x is going to be my u, and the natural logarithm of 1 plus 5x will be my v. Okay? So u is simply going to be sine x. To find v prime, we have a natural logarithm function composed with a linear function, so we're going to have to use the chain rule. The derivative of ln v is going to be 1 over 1 plus 5x times the derivative of the inner function, which is 5. Alright, so this is u v prime plus, now we're going to do v u prime, so v is the natural logarithm of 1 plus 5x times u prime, the derivative of sine x is cosine x. Okay? Alright, let's go ahead and simplify it a little bit further. So we're going to have y prime over y equals 5 sine x over 1 plus 5x plus cosine x times the natural logarithm of 1 plus 5x. Okay? Now we need to get y prime isolated, so to accomplish that, we're going to have to get rid of this y in the denominator on the left side. So we'll multiply y prime to both sides of the equation. So this y and this y divide each other out, and then you're going to have y prime, which is the derivative, equals 5 sine x divided by 1 plus 5x plus cosine x times the natural logarithm of 1 plus 5x times Now you see this y right here. This y we need to make a substitution. Initially y was equal to 1 plus 5x to the sine x. So we're going to make that substitution here. So instead of writing y, we just basically replace it with its value in the initial problem, which is 1 plus 5x to the sine x power. And this is your derivative of the original function. Okay? Alright. Now let's go ahead and try example number 2. For example 2, we have, let's assume we have the function, we're still looking for the derivative. Y equals x to the x plus 1 squared. Okay? Alright, so what we're going to do first is take the natural logarithm of both sides so we can bring down this power. So the natural logarithm of y equals the natural logarithm of x raised to the x plus 1 squared. Okay? So now we're going to differentiate this equation implicitly. Remember, the derivative of ln y is 1 over y, so we have, using the chain rule, derivative of ln y is 1 over y times y prime. Oh wait, before we do that, let's do a power down first, okay? So, or else we'll get ourselves in trouble on the right side. So, sorry about that. So let's just write ln y equals, now let's bring down this power, okay? So to bring down this power, we're going to use the property that we just talked about earlier. Basically, we have ln of, let me see how I expressed it earlier. Ln of a to the n power. You can bring down the power to the front. So basically it becomes n times ln of a. Okay? So this power comes to the front. So we're going to have x plus 1 quantity squared times the natural logarithm of x. Okay? Now this is much nicer to differentiate as opposed to differentiating this. So now we can differentiate implicitly. So we differentiate implicitly, we're going to have 1 over y times y prime equals, now here we have to use the product rule. Okay? So this is going to be my u, and this will be my v. And then we know what the product rule is, right? u v prime is equal to u times v prime plus v times u prime, as we did before. So u is going to simply be x plus 1 squared. V prime is the derivative of ln x, which is 1 over x. And then plus v, which is ln x, times the derivative of x plus 1 squared. Now, if you look at x plus 1 squared, this is a composition of a quadratic function and a linear function. So we're going to use the chain rule here. So it's going to become, using the power rule for the outer function, is going to be 2 times x plus 1. And then when you differentiate the inner function, the linear function x plus 1 is just simply going to be 1. Okay? Alright, now let's rewrite it in a condensed fashion. Y prime over y equals the quantity x plus 1 squared over x plus 2 times the natural logarithm of x times x plus 1. Okay, times x plus 1. Alright, now we're going to, times right here. Now we're going to, you know what, we're going to get rid of this y in the denominator. To accomplish that, we're going to multiply both sides by y. So multiply this side by y and multiply this entire equation by y. Okay? So what does that give us? This y is cancelled out, so we have y, just change the color of that. So we have y prime equals a quantity x plus 1 squared over x plus 2. Now I'm going to move this x plus 1 quantity to the right side so we don't think it's an argument for the natural logarithm. So 2 times x plus 1 times ln x multiplied by y. Okay? Alright, we know that initially y is x raised to the x plus 1 squared. So we're going to make that substitution here to finish up the problem. So we have y prime equals the quantity x plus 1 squared over x plus 2 times x plus 1 of the natural logarithm of x times the value of the value of y, the initial value of y, which is x x raised to the x plus 1 quantity squared. Alright, so this product is basically the derivative of our original function. Okay, so there goes your final answer. Alright, so thanks so much for taking the time to watch this video. You can feel free to subscribe to my channel. Just click up here. You can also share the contents of this video with your friends via Facebook or Twitter. More videos can be found on mathyourself.com. Thanks again and have a wonderful day.